Okay, I just thought I'd give a walkthrough of this question because it's a nice question, as in it's a tricky question to kind of work through, but there's quite a lot of interesting things in here. So the context is that it's about a student being asked to design an experiment. Okay, so we've got a cylinder that rolls down a slope and they want to use a timing circuit. So this is where your capacitor comes in, because capacitors take time to charge, discharge, and by measuring that discharge you can work out the time, you can calculate the time. Okay, so what we've got here, trying to measure the acceleration of a heavy cylinder as it rolled down an inclined slope of a constant gradient. So that indicates that it's going to be a nice steady acceleration. So this is a SUVAC kind of question. It's going to accelerate and they're linking it with electricity and they're designing an experiment. So there's quite a lot going on in this question. So this is actually from a practical paper and a AQA paper, but the ideas, if we take it through the steps, as I say, nice and clearly we'll find it how you break down difficult questions like this, so on paper 3 kind of stuff. Okay, he suggested he could use a capacitive resistor circuit blah 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 to measure the distance between 2 points. Okay, so things are going to accelerate, it's going to take time to accelerate. We can't obviously work out, or we can work out from this circuit, it's time to get from here to here, from A to B. From that we'll have to work out acceleration. So there's one of the equations for SUVAC I think will help. So these are 2 switches that will be opened as it passes over them, so it pushes something to open the switch. So at the moment the switches are closed. Okay. Once open, the switches stay open. You'll be released from rest as it opens, so it's starting with there, and then you're going to measure the voltage. Right. Okay, so let's just check. At the moment we have the capacitor connected to the battery, so not a problem. As soon as that rolls over, it's going to open that switch, which it says will stay open. So your capacitor will have charge and it's not going to be filled up again. As this rolls down, your capacitor is connected in a loop with your resistor, so it's going to be discharging. And it's going to keep discharging until you break that discharge circuit, that discharge loop. Okay, so we're going to have a voltage reading, which should be 12 volts, because that's what it is at the start, and then it will drop to a certain voltage. And by using that, you can measure the time difference. So, measure it, set it up, as described. He used 22 microfarads and 200k resistor in one of his results. The initial voltage was 12, yeah, and the final was 5.8, and the distance between the plungers is that. So measure the time, calculate the time taken for the cylinder to reach the second plunger. Well, using our capacitor network, our standard thing, we've got a discharge time, so we've got that idea of X, but don't put X. For voltage, we have a voltage after a certain time, starting with the original one, e to the minus t over CR. Okay, that's our basic equation, but we've shown our examiner that we know what we're talking about, and that it's about potential difference, because that's what we're reading, not X. Don't put X. Okay, so not X. So we want time, so we're going to need to rearrange that. Okay, so I suggest we have 2 values. Okay, so we've got a voltage and a voltage, so we don't have a fraction, we've actually got 2 different voltages. So what I'm going to do is I'm going to go for log of V equals log of V naught minus T over CR. Okay, and I want the time that we're after there, so I'm going to rearrange, take that across, so I'm going to end up with, let's make that positive, let's move that across to the other side. So I'm going to have, yeah, let's just do it in one step, guys. So I'm going to have V naught minus log of V, so I'm taking that across, and I'm going to take that across there, multiplied by CR should equal T. Okay, now if you want to do it in 2 steps, do it in 2 steps, it shouldn't make a difference. If you prefer, you could do it as a ratio. Okay, so maybe that's easier, in which case you could have log of V over V naught equals minus T over CR. And you can work that out and then take C and R across. So perhaps slightly neater, doesn't really matter too much. So what I'm going to do is I'm going to put in my value, so I'm going to have log of 12 minus log of 5.8 volts. Okay, so that from that, multiplied by capacitor, so 22 micro, so I'm going to do it correctly as an example, 10 to the minus 6 times by 200k, 200 times 10 to the 3 equals T. Okay, and if you put all those in, you don't need to show each individual step from that. I've shown alternative methods there, doesn't matter which way, but I've got my rearranged equation, I've used and input my data, so that's my second mark, and then my third mark is obviously for the answer. And if you put that in, you should end up with 3.2 seconds. Now let's just have a quick look. 3, 3, 2, 2 significant figures, so 3.2 seconds to SF. Okay, so worth remembering that. You don't need to write that, but it's just make you think about it. Okay, so we've got a time it takes to go from there to there. We've got a distance. Okay, distance is that, so that's going to be S for Suvat. We're trying to find the acceleration, so we're trying to find A. And you've got fairly constant things. Now it does say it will be released from rest, so U equals 0 as it opens up that first switch. So we have, let's go to the basics. So Suvat, we want that, so I'm just going to give a little tick for the A. We don't know V. We do know that is 0. We do know that the displacement is 2.5 meters, and we know that time is 3.2. Notice significant figures, yeah, it's all coming together now with that. We could put that if we were to be really fab. So, what do we got? We don't have V, so the equation you're going to need to use with that is gotta be S equals UT plus half AT squared, because we don't, that's the only equation without a V in. Okay, so that's going to go to 0. Okay, in which case let's rearrange 2S, take that across, equals AT squared. I'm going to take my T squared down. Okay, so I've rearranged it all in one, and what I end up with is, I'm going to put it down here to make it neater. I'm going to have 2 lots of displacement, so it's going to be 5 divided by 3.2 squared equals, you see, maths doesn't have to be that fancy, it doesn't have to be that awkward. And if you put that in, you'll end up with, again, 2 significant figures, 0.49 meters per second squared. Oops, excuse me, per second squared. Okay, so we've got a value, we've got the experiment, we've done it. It's designed to measure acceleration. There's more to it than that, and yes, it's about describing a procedure. So the calculations bit is quite nice because it's brought you through capacitors to give you times, timed merging. So fairly typical kind of paper 3 synoptic question. Okay, that style. They've also included, again with a quack mark, a quality written communication mark, describe the procedure. Okay, so not explain, just describe the procedure, including the measurements. Okay, explain how he, so that's an explain, how we should use the measurements to calculate the acceleration. Okay, so they're after a range. It's always after a range to get some sort of graph. So explaining, you're going to need some ideas about a graph. That would be kind of your crucial bit. So what are you going to need to measure? Well, everything that you've mentioned up here. So I'm going to start with titles. You know, just put it like that. So the measurements, well, you need your initial PD. On, let's make it obvious, capacitor, which is V0. Okay, we want the distance because we need that. Okay, we're only going to find, so let's go with that. So that's our initial PD. We needed, sorry, jumping ahead there. We need our other PD, so final PD. And again, I'm going to put V, just make it really obvious. So in our equations that we've got, we need our C and our R, but they're not measured, you're actually being given them. And you want the, down here, you need a distance as well. So values have been given in this place. So distance from, and again, I'm going to use their terminology, from S1 to S2. Okay, really nice and neat, nice and clear. They'll understand completely what you mean. Okay, and what I would do is say I would go for repeat readings. Okay, of V and V0 and V, or potentially I'll put this both, or change distance of S1 to S2. Okay, so that will give me differences in time. It would also give me distances in distance, so therefore you end up with different values in here. Now, for what you could do from that, you know, obviously your analysis is you need to get time, because it's all to do with time. So the okay, and again, there's quality. You know, for middle grade answer 4, 3 or 4, you could just say I'd calculate it using the equations above. For me, I'll be looking for a graph. Okay, and that's why I've put this bit in at the bottom here. So analysis, firstly you need to find or obtain get time t from calculation. Calculation in part A. There we go, in A. That's fine. Okay. Then, well, calculation, I'd put it in, I'd double check it, I'd use an average, so maybe average time. But again, this is a mid-grade answer for me. Average, time. And calc, that'll be 3 to 4 marks. So that's a bit limiting. What I would do would be harder for this. It depends on how much time you've got in the exam, of course. Paper 3 has slightly different timings per mark. What I'll be going for is this idea. So you've got different times, you've got different distances. That actually is a Suvat equation. So I would be tempted to plot t squared as a variable, s as the other variable, because this is where this comes in, you see, and then it should be nice, assuming it started at 0 at S1, then you should start at 0 there and you'll get a nice uniform graph. And the gradient of that, again you can describe this, the gradient of that, you would be equal to half A. I'd obviously put a few words with that, then I'd have a whole side of space for this, but yeah, if you put that time squared against that, just keep that in your head. S equals half a t squared, y equals mx plus nothing. Okay, so really thorough answer, full maximum 6 marks. Want a graph? What am I going to measure? Well, they've actually told you because they've given you all the values. Okay, so think of what you can change, think etc, etc. But what are you going to plot? Well, the first point is to get the time, because you want to find the acceleration. So this is where you get your variables. That's just a technique to use to get to one of the variables. Okay, right, hope you like that. That's a long question, but I do like it because it makes you understand there's actually lots of steps, but each one is a little technique on its own.